Hey guys, we're back. It's Thursday morning. We just got the nose cap on last night, and we're actually doing take two, which we almost never do. It's early, and I haven't had enough coffee yet. And I've been answering a ton of Facebook conversations and going back and forth with that. And I've had my head wrapped around this thing all night. So, yeah, we're going to work through this a little bit. There's been a lot of questions about what it looked like in the beginning and what it looks like now and why we did what we did. There's been some conversation about I should have done it a different way. I appreciate the input. I'm always here to listen to somebody that has constructive criticism or input, because if there's a better way to do it, somebody else has found a better way, then we're going to do that. But a lot of what I saw last night was just wrong information, pretending to be an expert in a field that they probably ought to stay out of. But anyway, that's all I'm going to say about that this time, because I got off on that tangent and I'm not going to do it again. The original construction had just fiberglass bat, one layer, about 2 inches thick in the nose of this thing. When we went back with 1 inch of foam between the aluminum structure, another 1 inch layer of aluminum foam over the entire structure. So the 2 layers of foam are together. They're screwed in with wood straps that we put in to make sure it's in place, and it's all glued in place. And then the last layer is a layer of Reflectex. I did that for several reasons. One, the foam, we can't get the foam. It's not spray foam. I didn't want spray foam in this structure right here because there's a lot of wiring going on, and the installation, the cost of it and everything, it's time. It's expensive. It's expensive to use in this application. But I need to seal the airflow up between this and this for a bunch of reasons. The first reason is Jordan's living in this thing, so he wants it as energy efficient and comfortable as possible. And two, when he's out on a job site, mice and rodents and bugs and all of that stuff, they're all attracted to smell. And if you've got airflow moving in and out, they're going to smell stuff going on inside. They're going to come try to find a home. We're going to put flashing down at the bottom. The sides are going to be completely sealed. The top's going to be completely sealed. So airflow is going to be minimal, or the airflow is not going to be in the front. We're going to take care of that. The next piece that I wanted to solve was the airflow that would happen between inside the living space and inside this nose cap. Heat or cold can travel in several different ways. If it's just a cold surface, then heat will travel to the cold surface. Heat always travels to cold. If there's an air gap, the thing will breathe. The hot air will create a higher pressure than the cold air, and it will just naturally start to seep. Won't be a lot if there's a little pinhole, but little pinholes become bigger problems over time. And then the Reflectex, once the 2 inches of foam are put together, that's going to stop all of your convection, basically, or heat. I'm sorry, it's conductive heat. It's going to slow the heat down from hot side to warm side or cold side, or vice versa. That's what R value is. It's basically, if this side's cold, this side's warm, the R value is trying to keep the heat from changing from one side to the other. When you get into other forms of heat, I heard somebody say that Reflectex, you got to stop the ultraviolet. Well, just for argument's sake, I'm 100% positive that ultraviolet light cannot get through a fiberglass cap. So ultraviolet light does not enter in. If you've got ultraviolet light in your building structure, you got a hole. And Reflectex isn't going to take care of a hole. Reflectex is designed to reflect the radiant heat that's kicking in and bounce it back so that it doesn't have a chance to get into the structure like rigid foam. So there's lots of different ways that heat happen, or cold. And when you get into heat and cold, then you get into condensation and all of those other things that go together. I had some people saying, well, you're sealing it up too tight. You're going to get condensation. Yes, we're going to seal this. The original factory design, underneath, it was completely open, no flashing, no nothing. There was a little bit of a plastic. You've seen the black plastic that they put under the underbelly of these things. There was a little bit of black plastic that was literally folded up with a couple of staples. And then they had originally insulation going all the way up into the roof. The problem with that, well, they did it because they want air to flow up. They don't care about energy efficiency or anything. The energy efficiency in lightweight campers, energy efficiency in campers is not even a conversation that's been had up until the last few years, when after COVID, people started trying to live in these things a lot more than they used to. We're focusing on energy efficiency, so I don't need to provide a highway for air to flow up. We're going to take care of any condensation, heat or cool issues. All of that's going to get taken care of mechanically. Mini splits are going into this thing, so we're going to have heating, cooling. We're not going to have propane heat, so I don't have to deal with any of the air movement that propane causes. The inefficiency that RV propane heaters, I think, are like 50 or 60% efficient at best. You can't even install a new heater in a residential application if it's under 90% now. So RV heat and propane is redonkulous at best. So condensation is going to be controlled mechanically. Ventilation is going to be controlled mechanically as we want it to be controlled. So I don't need air going through this structure. So the whole thing's going to get sealed off. I don't need rodents. When we open this up and we're actually getting ready to take the rest of the insulation off of the roof, when we open this thing up, there were literally mouse highways. There were tunnels in the insulation. There's tunnels in the roof. There's whole nest areas in the roof, where you can see the urine and mouse turds. And it's just, I wouldn't want to live in it. I'm quite certain Jordan doesn't want to live in it. So we're going to stop all that. As soon as we stop that, we've got to insulate it. That's the reason we did it. Condensation happens when there's airflow, because there's a heat transfer from one surface to another. If you think of a beer can, you're getting ready to watch the race and you're sitting out at the track and you've got a beer in your hands and it's ice cold. It's condensing because the can is cold. There's warm, moist air around the can and there's a circulation going on. If you eliminate the circulation, so you put a koozie over it, you're insulating the can and you've changed the surface temperature and you've stopped the airflow where the temperature difference is high. It's what we're doing here. It's not new science. It's not new technology. This is just simple physics that's been around, well, forever. We're just using that to our advantage. So 2 inches of foam, 1 layer of Reflectex. The Reflectex gives us, there's an air gap about 2 inches thick between the Reflectex and this, so that any of the heat that's blasting down on the cap during the summer is going to try to get reflected back and not allow it to continue into the styrofoam that's on this side. That's the way it's supposed to be installed. That's the way it got installed. All of the seams are taped with metal tape. That's the way you're supposed to do it. All of the wire penetrations that are in there are taped. That's the way you're supposed to do it. So by the manufacturer's guidelines, by any building insulation guidelines, by any high-end tight structure, the way that they're building new houses and engineering those, it's all built to that. This is not a traditional camper construction anymore. So if you've got questions, send them on. If you have any suggestions that actually go to new building construction with thermal efficiency in mind and all that kind of stuff, you want to have a conversation about it, hit the comment or give me a shout. Again, I don't know it all, but I know enough to build this thing to where we're at right now. I mentioned wiring. We actually found a wire right here in this location. It was a 120 volt wire and it had rubbed down. It was going through wood. We've seen it in metal, but I'd never seen this. It was going through the paneling here, going into the cabinet, and it had actually rubbed enough that it rubbed the insulation off. And it was on the hot wire side. It wasn't the neutral. It had rubbed far enough, and there was enough moisture between the panel inside and this that it had started to discolor. So it was creating heat at that spot. We've taken care of all of that. Down at the bottom, like I said, rodents can't get into this structure when we're done. We're filling that in the bottom. It's going to be flashed, and then we're going to spray it with polyurea. So when this thing's done, it's sealed up with poly. Rodents can't chew through poly. The stuff's too hard. And if I guess if they want to sit there and chew long enough, they will, but they don't have an appetite for it. It's just too difficult to chew. We found a gap in here when we opened up. There's a trim piece up here. There's a gap between the floor and the nose structure, and they just left it. They put a piece of trim over it. We're going to foam that in, get that level. And we're getting ready to pull the slides back out because we're into finishing on the inside. We're going to put the sheeting back up on the inside. We're going to get all of our gaps taken care of in here. The slides will be out. We're going to mask everything inside, and then we're going to spray the entire floor with waterproof polyurea, so that if there's any transitions, like the slides where the slide openings are, if Jordan walks into the camper with wet boots on, if he gets out of the shower and there's a leak onto the floor, the first thing that the whole camper is going to encounter is literally a waterproof tub, so to speak, so that the entire camper on the inside where the floor structure is just going to be waterproof. If the slide seal fails, if something goes wrong with that, the leak is going to happen onto a waterproof structure, not onto inside paneling. And then we'll finish it up with the rest of, we'll finish it up with the rest of our finishes, and it'll make more sense. We'll do a video on that, but I wanted to just I'm going to wrap it up, but I wanted to talk about how the structure of the nose starts to influence all the rest of this stuff. This is where the bedroom is. This is where we've worked with our camper. And after we did our camper and I took it out the first couple of times, I started to understand what was going on with some of the thermal bridging that I've talked about between the outside, the aluminum tubing, and the inside. All of that's been addressed here. So this thing's buttoned up. Noah will edit this. We'll get some pictures in the right spot so it makes sense, and we'll go from there. We're going to finish this. Last thing I'm going to say, this is super rough. We did a rough finish to understand the shape. Then we pulled the cap off. We did the finish work on the insulation. We put it back on. What's going to happen is we're going to finish this seam right here so that when it's done and we spray it with polyurea, the whole thing is going to transition right here and keep going around to the nose cap. So this entire seam, and then where the roof meets the cap, where the walls meet the roof, there's literally not going to be a single transition piece of a different material, whether it be TPO or fiberglass or fill-in. There's all of those traditional strips that you guys are going out and trying to caulk for, go out and caulk it every month, or in the wintertime, the caulk fails and water gets in. That's getting ready to happen now. All that's going to be gone. So it'll make more sense as we go. Keep watching, hit the subscribe button. We're on Instagram now, Gregory's Garage Indy. So we're doing pictures. Do all those kinds of things. Help us out on social media. We're doing slide rebuilds. So if you walk in and there's a wet floor in your slide, give us a call, get it in here. We can do a full slide rebuild in a couple of days. We're getting booked up for that. So give us a shout, help us out, bring more business so we can keep doing more of this. I'm going to get out of here. Later, guys.